Hello friends, this video on thermal properties of matter part 6 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos from part 1 to part 5 before going ahead with part 6. Now let us look at the different types of thermal expansion. There are three types of thermal expansion. The first is linear expansion, area expansion, and the volume expansion. I'm very sure that you must have got some idea about it by seeing their names. Now we'll discuss each one of them one by one in detail. So let us start with linear expansion. As the name suggests, linear. Whenever this term linear comes into picture, it has something to do with line, right? Linear is something line. Something in a straight line. Correct? So linear means expansion in length due to increase in temperature. As I told you, thermal expansion is increase in size due to increase in temperature. Now, if you think it, increase in size can be increase in length. It can be increase in the entire size, both length and breadth. So it can be increase in many ways. So when I specifically talk about increase in length due to increase in temperature, it is linear expansion. Let us suppose we have, say, an aluminium rod, which you can see in the screen. Now, when we heat this rod, it increases in length. Don't take it in real life scenario, because even if you heat an aluminium rod, it will not increase such drastically as it is being shown here. It is just to give you an idea that when you heat something and it increases in its length, however, that increase would be very small. That would be so small that maybe you cannot view it very properly with your naked eye, right? But whenever there is an increase in length, it is nothing but linear expansion. Now, with every expansion, there is a coefficient of that expansion. For example, when I talk of thermal expansion, there is something called coefficient of thermal expansion. What is that coefficient of thermal expansion? It is nothing but it is a parameter which tells how the size of an object changes with changing temperature, right? For example, I'm telling you that suppose you have a, say, metal rod. You heat it, the rod will increase in its length. But how is that length? How is the length of the rod increasing with temperature? How will I know that? So, how the length is increasing with temperature is determined by coefficient of linear expansion. So, coefficient of linear expansion is basically degree of linear expansion divided by the change in temperature. That means how much that particular object expanded or increased in length with respect to temperature. So, how do I write it mathematically? We'll see that. Now, linear, as I said, it is basically the degree of linear expansion. Now, before I write this, let us look at what is linear expansion. This term, linear expansion, is nothing but fractional change in length. So, linear expansion is nothing but fractional change in length. That means how is the length changing with respect to the original length. Now, let us suppose there is an object, let us say there is a rod whose initial length was L. When heated, its length increased by delta L. So, what would be the fractional change in length? It would be delta L divided by L. So, this is the fractional change in length. So, this is linear expansion. Now, this coefficient of linear expansion is degree of linear expansion with respect to temperature. That means we can say that degree of linear expansion is delta L by L, that is the linear expansion's change with respect to temperature, that is divided by delta T. So this would be our coefficient of linear expansion. Linear expansion is denoted by alpha L, where alpha denotes thermal expansion in general and L subscript is used for linear expansion. So that means this is equal to alpha L. Value of alpha L is characteristic of the material of the rod. That means the value of coefficient of linear expansion depends upon the material of the rod. For example, if you have a steel rod, maybe the coefficient of linear expansion is different than what you have for aluminum rod. So it depends, it varies with material to material, that how much linear expansion will take place with respect to temperature. So from this slide, we concluded that coefficient of linear expansion, that is alpha L, is equal to delta L divided by L per unit time, that is delta T. Or it is mostly denoted in this way in most of your textbooks, that is alpha L into delta T is equal to delta L by L. So what is area expansion? On very similar line, area expansion is increase in area due to increase in temperature, that is expansion in area due to increase in temperature. Let us suppose if you have something like a metal plate, as you can see here, when you heat it, it increases in its area. If you observe carefully, here you can see that there is an increase both lengthwise as well as widthwise. So there is effectively an increase in area. So this is known as area expansion. So as we discussed. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.